Hello, everyone, and welcome to today's webinar. If you've attended one of our previous webinars, welcome back. I'm so happy to introduce today's webinar. My name is Liliana Stefan, and I have been with Realization for almost 10 years. For those who are not familiar with Realization, here is a brief description. Realization was founded in 1999, and we have been at the leading edge of innovation in project management ever since. We were the first to introduce web-based project management, the first to introduce multi-project management software, the first to embed CCPM method in our software, and the list goes on. What we are proud of is the bottom line results of our customers, such as Boeing, Delta, the US Navy, and the US Air Force, Medtronic, and many others have achieved. By finishing more projects faster, in the last 17 years, our more than 300 customers have realized over $5 billion in hard savings. Our company and our clients have won many industry awards, including the France Edelman Award, Shingo Gold, and the U.S. Air Force Chief of Staff Excellence Award. What we will cover today is our next simple but powerful innovation in the area of project planning. Before introducing our speaker, I'd like to go over a few items. A recorded version of today's webinar will be sent to you later, just in case you need to refer back to any of the slides or you'd like to share it with your team. The webinar slides are available for download from the handout tab on your GoToWebinar control panel. You can ask questions at any time during the webinar. Just use the Q&A section in the control panel. We will answer all your questions, and if we run out of time, we'll email you the answer later after the webinar has ended. I would now like to introduce today's webinar, Sanjeev Gupta. Sanjeev is the founder and CEO of Realization.
Hello, everyone. So as Liliana said, what we will talk about today is something that is very simple. And what you will see, some of you, that for you who have been doing effective project management, that some of the concepts you have already been practicing. So it's not going to be a new rocket science concept. In fact, the beauty of the concept is that it's very straightforward and very simple. And we are just formalizing a lot of knowledge that we have accumulated over the last few years in working with our clients. The structure of the presentation is that I will first talk about some basic background information in terms of project plans, why do we create project plans, and what are the challenges we experience. So this is just to give you the background. Then we will talk about how to overcome these challenges. The first part in there is the concept. The second part there is we will show you how this concept can be applied or has been applied to some real life projects from very different environments. And finally, we will provide you some guidelines, some way of following this concept and implementing this concept on your own in reality. So with that, we will get started now. So we know that project plans are necessary because we want the various people, various team members working on the project to be synchronized and for management to have control in terms of what is going on with the project. So you need to synchronize teams, different silos, or even different organizations. You need to take these project plans and do a resource plan out of that. You need to plan the inputs coming from the vendors. Based on all these, you get some critical path information against which you can track the project status. And hopefully you can also issue priorities to people on a day-to-day basis. And we know that the core data that is there in a project plan is pretty straightforward. You have some tasks, dependencies between the tasks, some dates in terms of when do you need to finish certain milestones or the project, and some input dates. Now, the reality of projects, this is also not new to you, but the main point I want to make here is that for those of you who are familiar with the critical chain method, in critical chain method, what you provide is a time buffer, which is a protection against the tasks taking longer than anticipated or expected or planned. But in reality, when you work on projects, there are many other changes that happen in the project plan. It's not just that the tasks took longer, but the scope of the project can change. New tasks can be required to accomplish the same scope, because you thought that you will be able to achieve some technical outcome. But in reality, when you start working on it, you have to do some extra work. The sequence in which tasks can be done also changes, because when you typically plan a project, you are coming up with an ideal sequence, but in reality, based on how the project is doing, you might change the actual sequence. The resources on the project can change. And it's not just that in a multi-project environment where you have same resources working on multiple projects, that when you expected the resources to come onto your projects, they're not available. When you work on large infrastructure projects or construction projects, you assume that the labor force would be mobilized by a certain date, but the mobilization could be slower than that. So resource requirements or actual availability of resources both can change. And of course, you can have delayed inputs and rework. And what it means is that every input that goes into the project plan, every relevant input that we share on the first slide, each of those inputs is subject to change. So it's not just the task duration, but the tasks themselves, the dependency between the tasks, the resources, the input dates, all these can change. And with this dynamic environment, when we typically create highly detailed plans, one experience that many people who have with project plans is that only planners, the people who actually created the project plans or created the Gantt charts, only they understand their plans. No one else in the organization does. But more importantly, when your project plan is changing every day, the critical path also keeps changing every day, which means for all practical intents and purposes, the critical path information, which is the core of the information from a project, is unreliable, because the critical path of the information is the information that is used for determining the phasing of the resource requirements, is used for determining the priorities. And if the critical path information itself is changing every day, which means it is unusable and unreliable. And because planners are the only ones who understand the plans, plus the information coming from the plans is unreliable and unusable, what typically you see is that people have to be forced to update the project plans. They don't want to do it, but they have to be forced through some artificial means by creating some measurements like task update compliance, etc. And yet it is important for managers to manage their projects, so they develop their own back pocket plans against which they control and manage the project. And because these back pocket plans are really in the back pockets, the daily work schedules are managed ad hoc. They're not based on some uniform system of priorities, but it depends on what we feel comfortable doing, or it depends on who is the last person that called us to prioritize their work. And the formal project management systems tend to fall into disuse. And this problem is common not only with traditional critical path, but also critical chain systems. With critical chain, we saw that we were able to extend the life of an implementation um, by a lot, in the sense that typically project management systems, from an actual usage perspective, they fall into disuse pretty soon after they are implemented. And critical chain implementations tend to last a few years. But even with that, that is not enough. With all the problems that we talked about, the project management systems tend to fall into disuse, and this is not a good problem. In terms of just recapping the characteristics of a good project plan, I think one point that gets forgotten is that the project plan has to be user friendly, which means it has to be easy to visualize. If you cannot visualize your project plan and remember it, then it's not a useful project plan. And just a very quick historical perspective, when Gantt charts came into existence in the early 1900s, the Gantt charts were very simple and very visual tools. But I think what happened was, as computerization began to happen in 1950s and the PERT method came along, everyone felt that now we could overload the Gantt chart with a lot more tasks, lot more detail, and project plans just became very complicated. And I think it is kind of time to go back to simpler project plans. The second part, of course, which we covered, is that the information that we get from a project plan has got to be reliable, has got to be stable, which means our critical path has to be stable. I don't mean that the critical path of a project cannot change. Of course, it can change as the project goes on. But if it is flip-flopping, if it is going back and forth and every day you are getting a different priorities and a different critical path, that is not a desired situation. And finally, of course, it has to support synchronized execution, which we talked about in the beginning. The change that is required is, I think, first and foremost, a change in what we think of a project plan as. Instead of thinking of a project plan as a detailed schedule, we have to think of it as just as a master plan. What I mean by that is that instead of start and end dates for every activity, the project plan is just telling you what are the key milestone dates and the external commitments. Other dates are not meaningful. Instead of a detailed sequence in which the activities are performed, the project plan is just capturing the dependencies that exist between the different departments and teams. In terms of how a specific engineer or how a specific group is supposed to execute the technical aspect of the work, that is not what a project plan is. Similarly, a project plan is not a schedule for individual people. You're not going to use a project plan to say Joe is going to come in on Monday and finish the task by Friday, or Joe is going on vacation on a specific day. It is just a master plan for overall resource requirements. And finally, project plan, because of the nature of projects, the detailed just-in-time schedules that you have for your vendors and suppliers, those are not fruitful or useful in any way. Instead of that, project plan just tells you what are the key dates by which you want to target bringing all the inputs for the project in. And with that, let's go to the solution side. Solution actually is very simple, which is every project plan we think has to be a two-tier project plan. Tier 1, which is what we are calling tasks, and Tier 2, which we are calling subtasks and checklists. And what do we mean by Tier 1 versus Tier 2? Tier 1 is what is used for project management, and Tier 2 is what is used for task management. Tier 1 dependencies determine the critical path. Tier 2 dependencies between the subtasks are only for reference of the task manager, and they can change. Tier 1 does not need daily updates. Tier 2, you can get daily progress reports. For example, if you are laying the foundation in a construction project, you can get daily progress report from the site, but that is at the detailed subtask level, not at the task level. And of course, the Tier 2 is very dynamic and flexible. Tier 1, if you implement Tier 1 versus Tier 2 well, is relatively stable. It's not to say that Tier 1 level project plan will not change over the course of a project, especially if you have long projects, but it is relatively stable. You don't have to go and modify the project plan every week. Some details here. The Tier 2 dependencies that exist at the subtask level. So you will not have these dependencies flowing across tasks, which means the dependencies between subtasks are contained within a task. They don't go across tasks. The second and third points are important, which is the priority information, which is based on critical path or critical chain, flows from the task to the subtask, but status updates do not flow from subtask to the task automatically. And this is a very important point. What we are saying is, at a subtask level, you can do all the tracking you want, you can put all the information you want, but the duration update or the remaining duration update or the percentage complete update that you do at the task level is done by the task manager after understanding what is going on at the subtask level. And with that, I want to show you some real examples. And so there are some complicated projects and some simple projects. I want to illustrate all the different points that we talked about, the project plan being just a master plan versus a detailed schedule. So let's see the first of those plans. So the first plan that I have is a very simple engineer to order environment, but it is simple in the way it is being presented here. Just to give you a background, when we did the original implementation here, this project that you see on the screen was being planned with about 175 items. When we did the critical chain implementation, we reduced it to 80 tasks. And now with this two-tier structure, this project plan has only about 20 tasks. And there are about 20 people working on this project. This is the engineering phase of an engineer to order project. And the total duration of the project is about 2.5 months. And let's see what a detail below a task looks like. So what you see here is a list of subtasks that are below a task. So let's go back to the actual project plan. Let me explain the structure a little bit to you. So what you see across the top here is the different phases of the project, which is when you are doing the design, you have an initial package, then there is an initial review at the IPT, which is the integrated project team level. Based on that review, you come up with a final package and you do a final review, and then you make some final changes if required. And then you release these drawings either into purchasing or for installation in this. And on the left side, what you see is the different items, different sub-assemblies or different types of parts that go into this product. So there's some bushings, there is some hardware, and there's some installation stuff that needs to be done. And the overall project plan, as I said, is about 3 times 6, 18 tasks. And there are a couple of milestones in there, one project, and there are some details below these tasks. So again, let's look at the details. So for this specific hardware initial packaging for installations, so you can see the detailed subtasks that are there. So this is all the engineering that needs to be done for the different things that are required during the installation. And what you can see is that different types of resources are being used for this subtask. So for example, the assembly mechanic is being used for the first 4 subtasks versus a design engineer that is being used for the installation task. And the point I'm trying to make here is that a task can have cross-functional teams inside it. Now let's look at what happens to the critical path or the critical chain of this project. So what you see here is because we simplified the task network so much, it's a very linear project and the critical path is quite linear. It just goes from bushings to installations. And the more important piece is that it's obvious that this critical path is not going to change much during the course of its execution. And it's going to be pretty stable. And of course, it's a very it's visually much easier to grasp. So this is one example from engineer to order environment. Let's look at another example, which is a slightly more complicated project, which is this is for design and engineering of complicated systems. In this case, we have used as a reference design of satellites. So what you have in a satellite is the front-end engineering, which is really the system engineering phase, is uh, is very complicated, and there's a lot of iterative work that happens during that engineering. In this specific case, the original project plan was about 900 tasks, which we reduced to 155 when we did the first round of implementation. And now we have further reduced it to 30 tasks. And this is about 15 people working on this project for over a period of 5 months. So now let's look at some of the details here, what goes inside a task. So what you can see here is that there's some design engineers, strengths engineers, different disciplines again working on these tasks. And I will explain this point in detail later also. But the main thing here is that sometimes you have situations where different departments or different people from different departments, they're working on their work, on their designs, but there needs to be a constant flow of information back and forth. For example, whenever you're doing a complex system design as a satellite, you have situations where you have the someone who is worried about the space, someone who is worried about the temperature and the thermodynamics, someone who's worried about the communication aspects, and whatever design decisions you make in one area affect the design in the other area. So there's a lot of trade-off that goes on in terms of coming up with a good optimal design. And the flow of information is there's a lot of flow of information back and forth, which means in execution you want these tasks to be executed in tandem. You don't want them to be executed in different timelines. And once you capture these different pieces of work that are happening as subtasks inside a task, you will automatically force synchronization and tandem execution of these tasks. Let's look at the critical path of this project. So again, what you can see is it's kind of obvious that the critical path of this project is going to be quite stable. So it's not as linear a project as the first one. It's not as linear as the project for the first one, but it is it's obvious that it's a much more stable critical path. For people who are not familiar with critical chain, just a very quick thing, because you might be wondering what this magenta task and green tasks are. So these are tasks which are representing buffers. So these are not actual tasks, but these are just buffers of time that have been placed at different points in the project, so that even if there is a delay in an actual activity, it gets absorbed into the buffers. So really what you do is you take a critical path and you divide it into two parts. You divide it into a buffer and you divide it into the aggressive times for the tasks. So this is just for people who don't know much about critical chain. Let's look at a third project, which is much simpler. This is an example of a project which is an IT/installation project, which means you make some modifications to the system and then you go and install the system. So you're not developing new software, just doing some basic installation of a new IT system. And this specific project, it started with 80 tasks. Now it has been reduced down to 28 tasks. Again, about 12 to 15 people working on this for a period of about 3.5 months. And the specific thing I want to illustrate on this project plan is the idea of full kitting. So what you will see is a list of inputs that are required across different tasks in this project. So for example, the power item that you see here is required for the integration. The networking cables are required for the monitoring, and so on. The point being that all these inputs are needed at different times in the project. So let's go back to the project plan itself. But instead of saying that all these inputs will be managed on a just-in-time basis, we say that they will come in when we plan the project. We'll try to get them in before this entire phase starts. And the reason being that you don't know if some task could be done earlier or later. So anyway, the input dates that you came up with in the beginning are not reliable. Plus, you don't know if the people who are supplying those inputs will be on time or not. And trying to manage this interaction between the dynamism of the projects inside, as well as delays, etc., from the suppliers, that can make the project very unmanageable and create unnecessary delays. So the idea of full kitting is to bring all these inputs, or at least plan to bring all these inputs, on the front end of a phase, so that for the next 50, 60, 70 days, we don't have to worry about managing a lot of these inputs. And trying to manage this interaction between the dynamism of the projects inside, as well as delays, etc., from the suppliers, that can make the project very unmanageable and create unnecessary delays. So the idea of full kitting is to bring all these inputs on the front end of a phase so that for the next 50, 60, 70 days, we don't have to worry about managing a lot of these inputs. And you start a phase only when the full kit is 90%, 95% complete, so that you have very few inputs to manage coming in from vendors during the course of the project. Now let's look at the critical path of this project. And I think the point again is pretty simple. The critical path is only 2 plus 2, 4, 8 tasks. So about 8 tasks are on the critical path. And finally, I want to show you an example from aircraft maintenance, repair, and overhaul environment. This specific project, it had close to what they call 2,500 work cards. Work cards are the actual work that needs to be done they are issued to the supervisor. So the supervisor assigns people to a work card and says, go and do this work. So there were about 2,500 or so work cards on this aircraft for maintenance and repair and overhaul. When we did the implementation the first time around, we reduced this work cards to about 150 tasks, which means we clubbed together a lot of work cards into 150 tasks. And even that we found was a little bit onerous. And now this entire project plan is being managed with 18 tasks. And within these 18 tasks, there are about 235 subtasks. So the other advantage we gained here was that when we introduced the two-tier structure, we can actually have more subtasks. So originally we had to restrict it to 150 tasks because we wanted to keep the project plan manageable. But then we lost a lot of detail that was important for the supervisor to manage. So we were able to increase the number of subtasks from 150 to 235, but reduce the number of tasks in tier 1 from 150 to 18. And this is about 100 people working on this project for about 6 months. So try to imagine that. You have 100 people working for 6 months, and you can manage the entire project with 18 tasks. Let's look at the critical part of this project again. So the critical part itself is only five tasks, which means everyone in the organization from top to bottom knows what the critical part of the project is. They can memorize it. And of course, the project plan is much simpler to manage. Anytime you have a change, it happens at the work card level. So you just go in, add your checklist, change your subtasks, and that is all you need to do. And at the high level, the project plan will remain stable. So with this, these are the project plans I want to share. So what I have shared with you is the basic concept of a two-tier. Then I have shown you 4 different examples from different environments. And now finally, what I want to just share with you is the guidelines for defining a task. So the guidelines, again, for those of you who are experienced in project management or have been practicing some form of critical change project management, you know these things, but it's good to capture them. That it's a chunk of work that should be done in tandem and without interruptions. So both the points are important. So if I am an engineer and I have to execute 5 different steps, I want to execute all these 5 steps without any interruptions in succession. So this is one example of where you will take 5 tasks and chunk them into a higher level task, and those 5 steps will become a subtask. The other example is what I talked about, where different disciplines are working in tandem. So even though they could be separate tasks, we declare them as subtasks with a higher level task. So that is another example. And by the way, another benefit of the subtask here is all the iterative loops that happen at the subtask level, not at the task level. A corollary is that more than one type of resource can work on the same task, and typically these tasks are between 1 to 4 weeks of duration. One more piece, in terms of the effort that goes in, typically what we are finding now is that with 2 tiers, of course there are some tasks which have even much more effort, but in terms of effort, they represent about 50 to 500 hours of effort, each of these tasks. When we go into large infrastructure and construction projects, they can actually represent 5,000 hours of effort or 10,000 hours of effort each task. The recommended process, again, this is a recommended process. I'm sure there are multiple ways of getting the same output, but one recommended process is that instead of doing bottoms-up project planning, you do top-down project planning. So instead of starting with very detailed tasks, understanding what is the work going on, you start at the top, you try to define what are the major phases in this project, then you break these phases into meaningful deliverables. So if you remember when I showed you the project plan, there were phases at the top, and on the left side there were the different deliverables like bushings and hardware. So that is what we are calling as scope items or deliverables. And then you just need to take these tasks that are required to produce those deliverables in each phase. So you break each phase into tasks, and inside each task you can list the detailed activities and checklists, and you can aggregate the inputs that are required for those tasks into one full kitting list, one or more full kitting lists. And this is kind of what we are saying, that you have a task which is the hollow rectangle. Inside that you have subtasks, which are these solid rectangles, and then your checklist below that. And we talked about the idea of full kitting already. So before we end this, I encourage you to type in whatever questions you have, and I'll try my best to answer those questions today, or we can also follow by email if we don't have time to answer all those questions. And in terms of the next steps, before I hand it over to Liliana, so you are welcome to have a 45-minute call with one of our experts if you want to understand this concept in detail in terms of how it can be applied to your projects. Or send us one of your projects and we will take our best guess at what this two-tier structure will look like on your projects and send it back to you. And we can even do on-site workshops if you want. So with this, I want to hand it over back to Liliana.
Thank you, Sanjeev. Before going into the question and answers time, we're going to run a quick poll. The question is, which of the following actions are you more likely to take today? I'll give you a few seconds to respond. All right, we're closing the poll now. Thank you everyone for completing your poll. We're now going to begin answering the questions that you've submitted during today's presentation. As Sanjeev mentioned, you can still submit questions through the questions pane in your attendee control panel, and we'll answer them even after the webinar has ended. We'll send you an email with all the answers. Sanjeev?
So one of the questions was actually a comment, and I apologize for that. So it looks like my voice was fading in and out. So if you were not able to follow my presentation, I apologize for that. You can send us your questions and I will try my best to answer those questions by email. Okay, so one of the questions is, for the project plan, if you assign multiple resources in tier 2 tasks, then how does resource assignment happen for tier 1 tasks? So at tier 1 task level, the answer is simple, that we can actually assign multiple resources. So we don't restrict one resource per tier 1 task. You can assign multiple skill types with different units at tier 1 level. So this was one question. Okay, the second question is a very specific question to people who are using our Concerto software. And the question is, how is this tier 2 information versus tier 1 information presented during execution? So this is something we can share with you in detail to the person who asked this question. But the point is that both tier 1 and tier 2 information can be updated by the respective people in execution. And if someone has to look at tier 1 information as well as tier 2 information, so there is also a consolidated list of tasks and subtasks that a person can get. There was another question about when, and this is a good one. So the question is that there is an example of an IT project, and this IT project designs multiple phases, which means there's a design phase, a build phase, a test phase, and a release phase, and also the deployment at multiple sites. And the question that is being asked is that would this be one plan or multiple plans? And I think it depends, and I hate to give the answer of it depends, so I'll try to be more definitive. The installation at each site could potentially be a separate plan, but the design, build, and test and release part could be all into one project plan. And the reason that the deployment at multiple sites you might want to capture in different plans is their timings could be all off in terms of, sometimes we have seen that the installation of a system that you have designed and built, uh, it can happen in, as far apart as 6 to 9 months apart. So you want to manage that part as separately. But again, it depends on what your resources are, how the resources are being shared, who is the project manager. So it depends on a few factors, but the quick answer is that we try to keep the different phases of a project into one project plan, and a two-tier structure does enable that much better. But if you are managing um, different sites and the work is not necessarily synchronized in terms of timing, then that can go into multiple project plans. Another question is, who is responsible for setting the boundaries of a task? I think that's a great question. So I think the right person, if you are talking about a single project, is the project manager. So the project manager should be able to define the tasks, because they know at which level they want to manage the project and at which level the critical path should be determined. But when you go into a multi-project environment where you are doing similar types of projects over time, then you can actually create templates that capture these definitions. And those templates can be used as references for creating project plans. So you can create what we call reference networks. The idea is not to do cut and paste, but the idea is there is a reference network here, and you can look at that to see how you want to define projects in your project plan. Okay, there is another question which is about how do you calculate task percentage complete? So the answer there is that you are monitoring subtasks. So you are monitoring the completion of subtasks. And two extreme examples is there's just volume of work. There's a list of things that need to be done. And let's say you have to do 50 items, and all of them take roughly a day each to make it simple. When you have completed 25 items, you know that you have completed 50% of the task, or there are 25 days remaining for the higher level task to be completed. Or if it is a linear sequence, the same thing, you can calculate based on the linear sequence how much more time is remaining for the higher level task. But the main point that we are making here is that it should not be an automatic translation of data from lower level to higher level. The reason being that the subtask data, we are saying there's a lot of flexibility in those dependencies. And whether you even want to keep it up to date, the subtask, that is left to the discretion of the task manager. So the data and the calculations do not automatically flow in terms of completion from lower level to higher level. They are there for a reference, but the task manager should use their judgment. And similarly, what can also happen is your data might say that you need 25 more days, but the task manager knows that they can get additional resources or do something from an expediting perspective to get the task completed faster. There was another question about, can tier 2 move outside tier 1? No, it cannot. Okay, there's a good question about how to use Fullkit for aggregating multiple inputs. Could you show any example? So in the example that I showed you in the IT projects, so there were 5 different tasks that needed the inputs, but we aggregated all those inputs at the beginning of the first task. When you see the PowerPoint, you will see what I mean. So look at the IT project, look at the Fullkit point, and what goes into that Fullkit is actually inputs that are required not just for that task, but also the subsequent tasks. So there are a few more questions which we'll have to follow up with on an individual basis. Again, thanks for joining this webinar, and I'm sorry for the audio problems that you might have experienced, and we will find out what can be corrected for the future. And thanks again. Liliana?
Thank you, Sanjeev, and thank you everyone for attending today's webinar. If you have any questions, don't hesitate to contact us. We will send you a follow-up email tomorrow with a link to view the recording of today's webinar, as well as the slides if you haven't downloaded them from the handout section. On behalf of Realization, thank you for joining us today and have a great rest of your day.